Welcome to Chapter 7, Ionic Equilibria. Now we shall continue with sketching titration curve for strong acid and weak base. Now let's look at the equation. We have strong acid and weak base, and then so with the salt, is it neutral, acidic, or basic? Okay, so remember, if we have strong acid and weak base, so we follow the strong one, so that will be the acid. So it is acidic salt, okay, to be fast. Okay, so remember, the analyte is weak base, and then the titrant is strong acid. Okay, so now remember, when we plot the titration curve, there are 3 points. Okay, if not the strong acid and strong base, we have 3 points to draw. That is when before titration begins, another one is at equivalence point, another one is after equivalence point. Okay, so now before titration means that we only have analyte. Okay, the analyte is ammonia. It is a weak base. Okay, so if it's a weak base, we will expect that the pH is more than 7. Okay, of course you can do calculation if Ka is provided. Remember, this is a weak base, so we cannot just use pOH equals to negative log OH minus. Okay, then after that, when you start to titrate, okay, we will have acidic salts form. At the same time, the weak base not yet fully react. Okay, so we will have what we call a buffer region where the pH will maintain. Okay, then we keep on titrate until we reach our equivalence point. Okay, remember, when we sketch the titration curve, remember, 7 you must write it down. The other numbers, if we don't write it down, is okay because it's just a sketch, but we must show number 7 because we want to know whether the equivalence point is above or below, or is it exactly 7, to show whether it is a neutral salt, acidic salt, or basic salt. Okay, in this case we have acidic salt. So if acidic salt means the pH will be less than 7. So you can see the equivalence point is less than 7. Okay, and remember, you draw the stick here, the range must be 3.5, okay, roughly about 3.5 until 6.5 for strong acid and weak base. And then you plot the equivalence point in the middle of the strip. Okay, then again you continue with the titration, adding more HCl, and then finally you will get salt. Okay, you will get salt. The salt is still acidic salt. At the same time, you will get strong acid, HCl excess. That's why our pH will be also less than 7. Okay, so again, remember, for strong acid and weak base, you have to see which one is in the conical flask, which one is the analyte. If you have weak base as the analyte, you cannot calculate the pH as pH equals to 14 minus pOH, where pOH equals to negative log concentration straight away. This is a weak base. It partially dissociates. You need the ice table in order to get pOH. Then only you get pH equals to 14 minus pOH. If the question doesn't give you the concentration of ammonia, then what you do is you just put it more than 7. Okay, because this is a weak base. Okay, then don't forget equivalence point is very important. We know that this is acidic salt, so it is the pH is less than 7. So you must draw lower than 7, and remember 7 you must label. Okay, and then don't forget the volume of the titrant. How much? Okay, for this one you can always use MAVA per MBVB equals to A per B. Okay, that's all for the titration curve for strong acid and weak base.